Buongiorno a tutti, cercherei di partire anche velocemente perché è una giornata intensa, ci sono molti interventi molto interessanti, vogliamo lasciare a tutti il tempo per parlare approfonditamente delle questioni che ci interessano. Allora, questo è... Scusate, inizierò in inglese per il nostro ospite e poi magari passerò all'italiano in una fase successiva. So this is the, let's say, the third stop of the journey that Fondazione Bordoni has started in the world of digital innovation. We think that we are in a very critical and very interesting situation where three different and very important innovation are coming out in the digital world, 5G, artificial intelligence, blockchain, and in general all the world of the distributed network, distributed web, which is the argument of today. In September, we started with a Seminario Bordoni dedicated to blockchain, to the general idea of the blockchain. Then 1 month ago, we had a very interesting seminario concerning 5G and all the innovation on 5G and artificial intelligence in 5G and so on, blockchain and so on. Today, the idea is to talk about the distributed web. This is the main character of our seminario today. And when we talk about distributed web, we also talk about cloud. And as I will say in a short while, our main point today will be the analysis of a crucial crossroad, another crossroad, which is a crossroad between a possible distributed web in the future of a centralized web, a web in which the great platforms are the winning solution. We want to discuss this. We are wide open. I have my ideas, and you will see what the main idea concerning distribution and centralization, what I think about it. But in general, the goal of Fondazione Bordoni is that of starting a discussion concerning a theme we consider very important for the future in general and in particular for the Italian industry. In particular, we have invited today Professor Gilles Fedak, and I really insisted in having him, and I'm very happy that he accepted our invitation, for two main reasons. He, in my opinion, is new startup, let's call it, is an example of the right way in which technological innovation has to be introduced in the let's call it real world, but in the world of application in every possible kind of application that we are interested in. When I say it's the right example, because Gilles Fedak is a research scientist at INRIA, which is a very, very important research center in France, and he devoted almost 15 years of his life, and he did research concerning distributed computation, and he was a leading scientist in this field. And his group is one of the excellence group in Europe and I would say in the world. And starting from that experience, Professor Fedak then decided to come out in the real world with a new startup, which is iExec. So he is the CEO and co-founder of this a very important startup. I think is one of the most successful, at least European, ICO in the world of cryptocurrencies. Anyway, it's, I think that it's a very interesting and important experience that we would like to hear from his very voice. He will talk about this, I think he will talk about distributed computation, Internet of Things, blockchain, and data market, because I know that those are the main elements that makes iExec alive and kicking in this moment. So we are very, very interested, and we thank again Gilles for coming to Rome to say something about it. My key question today, or let's say the key question that Fondazione Bordoni wants to ask to the industry, and we would like to discuss about this point. And the point is centralized or distributed web. Now I'm going to switch to Italian, just because I want to weigh each one of my words, because I want to be very precise, and I can do this only in my mother tongue, so I don't want to use general words or not specific words to describe what I want to say, because I want to be very specific. But the slides are still in English, so you can follow the general idea of what I'm going to say. Ok, quindi torno all'italiano. In questa slide voglio dire semplicemente quali sono le domande fondamentali che noi ci vogliamo porre e i temi che vogliamo porre all'attenzione della discussione nel nostro Paese. Ovviamente sono temi sui quali la Fondazione Bordoni è al lavoro, su tutti i temi dei quali parlerò e sui quali la Fondazione Bordoni ha le competenze, come vedrete anche, diciamo anche nel seminario di oggi, però voglio mettere in evidenza quali sono, almeno dal mio punto di vista, voglio dire qual è la questione fondamentale, qual è il bivio davanti al quale, del quale parlavo prima, davanti al quale ci troviamo, un bivio nel quale non sappiamo ancora se andremo a destra o a sinistra o se andremo verso il web centralizzato o il web distribuito, però qualche idea comincia ad emergere, comprenderete da quello che dirò qual è il mio punto di vista personale su questo, ma questo conta relativamente poco. Allora, il punto fondamentale è che 5G e intelligenza artificiale, quindi 5G e AI, richiedono e abilitano un web distribuito, quindi hanno entrambi i ruoli. Edge computing sicuramente sarà qualcosa, per esempio vedevo recentemente che negli Stati Uniti AT&T ha messo l'edge computing come argomento principale, uno dei suoi pillar nello sviluppo della futura rete di AT&T sul territorio degli Stati Uniti, cioè il fatto che la computazione si sposta ai bordi, lì dove ovviamente una rete molto efficiente arriva, una rete in fibra, una rete super efficiente che collegherà tutto con tempi di latenza molto bassi, ma che non si potrà permettere, pur avendo tempi di latenza molto bassi, di avere una computazione centralizzata. La computazione dovrà essere distribuita. Quindi edge computing, l'Internet of Things con le microtransazioni e la questione di chi è il proprietario dei dati e dell'abilitazione dei singoli ad essere proprietari dei propri dati, data crunching, cioè algoritmi che dovranno funzionare efficientissimamente al bordo della rete e non al centro, contrariamente a quello che abbiamo sempre pensato, cyber security ottenuta non elevando muri d'acciaio sempre più spessi, ma col meccanismo di encrypt and distribute, cioè codifica e poi distribuiscilo e rendilo difficile, rompilo in tanti pezzettini che distribuisci dovunque, ricostruire tutto questo potrebbe essere molto complicato. Anche questo va nella direzione di un web distribuito. E poi, punto fondamentale, ogni computer che diventa una cellula di un computer che occupa tutto il mondo, fatto da tanti computer collegati fra loro, e addirittura, qualcuno lo chiama così, esiste IPFS, che vuol dire esattamente Interplanetary File System, e si pone il problema di come collegare i nostri computer quando saremo andati su Marte. Questo è meraviglioso, da un'idea di qual è la visione del futuro che hanno questi i progettisti dell'Interplanetary File System, ma io penso che anche iExec sarà un altro esempio importante, diciamo, di questo mondo. I computer che diventano cellule di un supercomputer che occupa tutto il mondo. Al contrario, e qui appunto capirete come la penso, la centralizzazione sembra essere molto, molto popolare al giorno d'oggi. E in particolare noi andiamo nella direzione di avere pochi, ho sottolineato quei certificati, pochi certificati data center, cioè diminuiamoli, chiudiamo i data center, devono essere certificati, pochi, protetti, blindati possibilmente, pochi supercomputers, perché in quanto super ovviamente non possono essere distribuiti dovunque, e poche super piattaforme. Ogni cosa che potete immaginare as a service. Ovviamente questa cosa non è impedita in una, cioè che ogni cosa possa diventare un servizio non è impedita nella versione distribuita, ma sicuramente l'altra direzione è quella che ho indicato lì sotto, una direzione super concentrata. Abbiamo bisogno di reti super efficienti in un mondo super concentrato? Sì. Ne abbiamo bisogno in un mondo super distribuito? Assolutamente sì, e anzi sono gli abilitatori della distribuzione. Quindi io penso che il 5G per esempio abbia il suo luogo di elezione in un mondo distribuito. Domanda difficile, in quale direzione andare? Il mondo sembra andare esattamente nella direzione numero 2 e lo vedremo nella discussione di oggi, per questo sono molto provocatorio diciamo nella mia introduzione, e viceversa la scienza, l'evoluzione naturale sembra andare nella direzione opposta. E allora come tutte le volte in cui c'è una domanda difficile bisogna ricorrere ai padri fondatori, e che è quello che ho fatto, e quindi vi presento Paul Baran, che è colui che ha inventato il packet switching, e quindi possiamo dire che è l'inventore o il super abilitatore di internet e di tutto quello che vediamo. Lo vediamo di fronte a una slide nella quale spiega al mondo, in uno dei suoi ultimi seminari, perché purtroppo non è più con noi, in uno dei suoi ultimi seminari spiega la differenza fra centralizzato, distribuito e decentralizzato. E ovviamente il suo sogno originario, è ben chiaro in questa slide, no? Dalla versione centralizzata alla quale lui era abituato nel tempo in cui internet nasceva, alla versione decentralizzata in cui i centri diventano pochi, sono pochi e cominciano a distribuire il web, alla versione meshed, completamente distribuita, un mondo nel quale ogni nodo parla con ogni altro nodo. Attualmente la situazione, internet come adesso è un internet centralizzato e fatemi dire è altamente concentrato. AWS, che è la super piattaforma di Amazon, ha il 33% di market share, cioè siamo già in una situazione di super concentrazione. I primi 4 operatori che si occupano di piattaforme vanno oltre il 60% del mercato e il primo è maggiore della somma degli altri 3. Qualsiasi indice di concentrazione ci direbbe che siamo in presenza di un'alta concentrazione. Ma non solo questo, ci sono dei fuoriservizio catastrofici. Volevo fare l'elenco qui, ma mi ci volevano altre 3 o 4 slide di questi sistemi che mandano fuori servizio contemporaneamente tutti i centri più importanti. I cyber attacks ovviamente sono concentrati perché c'è un single point of failure, c'è un unico punto che deve essere attaccato e quindi ovviamente vengono attaccati e poi sono energy hungry, tutto tranne che verde. E poi c'è la domanda: chi controlla il web? Magari dovremmo fare un altro seminario Bordoni per parlare di quello che sta accadendo nel caso di Google e dei sistemi operativi, però insomma è di Huawei, questo volevo dire, però sicuramente la centralizzazione, il fatto che ci siano pochi che controllano le piattaforme è un tema sicuramente interessante. Qual era il sogno di Paul Baran? Il sogno era viceversa una internet distribuita. Quando internet è nata perché doveva resistere Rand, quando è arrivata la commissione di immaginare qualcosa in cui dovesse funzionare packet switching e internet, perché doveva resistere a un attacco nucleare in cui metà della rete veniva completamente distrutta e l'altra metà, o un decimo, continuava a funzionare. Quindi un'internet distribuita. E quindi nessun single point of failure. Non c'è un punto da attaccare perché internet è ovunque, resistente di conseguenza, verde e quindi sustainable, che è un tema fondamentale per noi, e poi ogni nodo conta, ogni nodo è importante nella gestione della rete. Immaginate, è il contrario del certificare i nodi. Non devo certificare nulla, chiunque si vuole collegare a internet si collega, chiunque si vuole collegare al web 3.0 si collega e mette a disposizione il proprio storage e il proprio e la propria capacità di calcolo, abilitata da strumenti come quelli di cui sentiremo parlare fra un attimo. Ho finito. Ho una sola domanda per Gilles, al quale sto per dare la parola. Il sogno di Paul Baran sta per diventare vero grazie a iExec e a tutti gli altri che stanno lavorando in questa direzione per un web distribuito. Spero che Gilles risponda a questa domanda. Grazie.
So, thank you very much for this great introduction and for this invitation. I'm really happy and honored to be here talking about what we are doing and what I have done as a researcher before. So today I'm going to talk about iExec. This is our approach for doing decentralized cloud computing. There are certainly some other approaches, but I think we are one of the first ones trying to achieve this using those decentralization technologies that are coming from blockchain and other things. So as it has been said before, I was a researcher at INRIA, and since 2016, I've created this company that is running since 2 years about. So it's a rather new adventure for me. We are 25 people working at iExec, and we are located in Lyon, in France. Okay. Okay, so before going right in the question of how to do decentralized cloud computing, I will give a little bit of background, in a history background, to see where the idea comes from, what has been done before, and to understand why we make it different now. I will give an overview, an introduction of the iExec architecture, just to understand, how blockchain are being used, how those new technology are being used, more than actually trying to understand how it works, because that will require a little bit of time and effort for everyone to explain everything. I will give some brief use cases here again to understand what can we do now using those kind of approach that was, in my opinion, very difficult to achieve before. And then I will give a short conclusion. So using idle PCs on the internet to execute very large applications, this is not a new idea. Actually, I was really happy to find this quote in a scientific paper published in 1982. And you know that in computer science and the IT industry, we have a sort of cosmogonia. We think that the origin of everything is in Palo Alto, in the Rank Xerox lab. And this is actually true. So the origin of this idea comes from also Palo Alto. So I was really happy to find this citation. So as you can see in the 80s, and this is really the idea. You're using many PCs. So here it was in a lab. When they are idle, when they don't do anything, and you try to group them together, to put them together to execute something big. So this is really the idea of a worldwide supercomputer. And from this paper, you already have some, the main idea of doing what we call cycle stealing. So the fact that you can use a machine when they are idle. And so, of course, they observed that machines were more available during nighttime because, of course, people do not work. That's why. And so they used to call that vampire program or vampire computing because it was mostly active during nighttime. So this idea basically grew up during the 90s and the early 2000s. And it brings together, there have been some different flavors for doing that. So the origin, in my opinion, really lies in peer-to-peer systems. So peer-to-peer systems, they have a certain kind of characteristics. It's free to join, anyone can enter the network. It's mostly anonymous, you don't have to provide your identity. It was doing for usually one kind of application that was file sharing. And the way you design the protocol for doing that is that the infrastructure is going to be unmanaged. It has to be scalable, it has to be resilient. The second way of doing distributed computing was grid computing. So grid computing, it was mostly used in the scientific area, in particular in Europe. So so think about the CERN, for instance. So the CERN, it's many labs in Europe and worldwide. And the idea here is to put together all their computing resources, so mostly supercomputer or high-performance computing centers. And the idea is to share those resources, to create a kind of federation. And basically, this is the way the world stands. So if you are allowed to use the supercomputer of your institution, then you enter a kind of network, and this will allow you to use the other supercomputers from the other labs that belong to this so-called virtual organization. So here, there is a strong identity, strong security. You have to provide, you have to provide the fact that you have an identity that belongs to a certain lab, and this gives you the right to access other resources. The domain of application was mainly around high-throughput computing. And later, maybe more in the 2000s, we saw the emergence of cloud computing. So here, that is mostly a commercial version of distributed computing. The origin, the enabling technology was virtualization for that. And at the moment, it hosts any kind of application, so mostly the web application, big data, etc. So what I've been working on as a researcher for almost 15 years, doing my PhD thesis and after working at INUIA, was a model called desktop grid computing. So desktop grid computing, as the name does not exactly suggest, it's not only about desktop, it's really about putting together some distributed computing infrastructure, I would say loosely coupled in the sense that you may or may not have a permanent connection, you may have trusted resources, untrusted resources, and what you have tried to do is to create a sort of coherent view of everything. So this is, as a researcher, a model that I've been investigated in all possible directions. We wrote papers about programming model, resilience, security, data management, etc., etc., etc. Okay, so I will do a short recap about blockchain, but as I understood, you're already familiar with that. Just to understand exactly what matters for us when we talk about blockchain. So blockchain, basically, this is the technology behind Bitcoin, cryptocurrency. So think it as sort of distributed ledger, and basically the blockchain stores every transaction. So if I send you a Bitcoin, this transaction will be stored in this distributed ledger. There are some characteristics which are very important to understand. First, transactions are immutable. Once a transaction is added in the blockchain, it cannot be removed by anyone. And that's basically what gives the security of the ledger. So that's one thing. The second thing that is really important in blockchain is this notion of consensus protocol. So a consensus protocol, it means that all the nodes in the network are going to agree together about what is the state of the ledger. Okay, so this notion of consensus is extremely important in the sense that this what allows to build a distributed system where no third party is necessary. The second generation of blockchain, Ethereum is the main known, appeared basically in 2015, something like that. It's the same idea of Bitcoin, plus you add the fact that you can execute program. So with Ethereum, you can create program that we call smart contract. You can deploy those programs on the blockchain, and the way those programs are going to be executed follows the same ID than the distributed ledger. This means that you cannot, if you execute a smart contract, there will be the same level of security in executing this program than when you transact a Bitcoin from one to another. So you cannot modify the execution of a program. It's extremely secure, it's transparent, and the result of the program, when it has been executed, is stored on the blockchain. So the state of the blockchain advances according to the execution of the program. So what we call dApps, or decentralized application, these are the applications that are built on top of those smart contracts. Okay? And so something that is sometimes not so well understood, or people are, not emphasize this. It's the characteristics of those dApps. And this is something really unique and really different than what exists, for instance, in traditional distributed computing. So, for instance, people expect some sort of behavior from their dApps. So a dApp is autonomous. It means that you pay once for the deployment of your smart contract on Ethereum, but when it's there, it's there. So each time there will be a transaction on Ethereum that will trigger the smart contract will be executed. You don't have to pay for that. So you deploy once and it runs forever. And more important, no one can stop it. No one can modify the program. So these are really key characteristics. So even us, so iExec, when we deploy our smart contract on the blockchain, we cannot modify the smart contract. So this is extremely important because of the governance and economics. When you say these are the rules for the governance, these are the rules for the economic, it's there on the blockchain and you cannot modify this. So this is something really, really important. Blockchain distributed ledger, smart contract, dApps. The third evolution of blockchain, I think this is my opinion at the moment, it's not so established, I would say, it's my personal opinion. I think that probably the next big thing for a public blockchain are going to be what we call decentralized marketplace. So what is a decentralized marketplace? It's the idea of creating a marketplace on top of public blockchain so that people can do business in a peer-to-peer way without going to, through a third party. So typically in the 15 last years, the internet has grown mainly thanks to those platforms. So typically Uber, eBay, Airbnb, etc. So those marketplaces, those centralized marketplaces, what they are doing is that they do a matchmaking between a consumer and a provider. So you're looking for an apartment, an Airbnb, you will find a provider and a consumer. So here the idea is that we want to do the same thing. Of course, it's a marketplace, so the matchmaking still exists, but we don't want to go through Uber or whatever. We want to we want to establish some sort of decentralized protocol so that people can do business together. And why I think this is important? This is important because it's going to create free markets. And free markets, so for instance, with those platforms, you have all kinds of issues like Uber. So when Uber changes, the fees for the drivers, it creates all kinds of issues. Here, basically, the idea is that the governance of this free market, the economic of the free market, is managed on-chain, on the blockchain, so it's transparent for everyone. If you agree with that, you enter this market. There is no censorship. There is no way iExec as a company, we can forbid someone to enter the market. Plus, there is no fee. There is no transaction fee. So this can create a very interesting way of creating markets. Okay, so now you have all the basics to understand what iExec is doing. So we are doing decentralized cloud computing, blockchain-based decentralized computing. So the idea is to create a decentralized marketplace for computing resources, which means that we allow everyone to monetize their servers, their applications, or their data sets. So that's basically what you find in the cloud. So we're using Ethereum. And as you can understand, providers and requesters can interact in a peer-to-peer way without central authority. So why do we think this matters? I think for two reasons. First one is that we have the emergence of the decentralized application, and they actually do need an infrastructure. So what you have to understand is that on the blockchain, you can only interact with the blockchain. So, for real-world application, you have to go off-chain. You have to find information everywhere, do computation, etc. So they need a new infrastructure and a new way of creating this infrastructure. With the assumption, for instance, an application being autonomous, you need a new way to create an infrastructure so that the application is going to be autonomous. And at the moment, there's nothing to do that. The second reason is that because it's going to be a free market, we think that at the end, this can allow to build, I mean, this new approach is going to be much more competitive than the traditional cloud computing. And hopefully, we hope that at the end, we're going to have a cheaper and greener and more efficient way of doing the cloud computing than the traditional centralized cloud. So for what kind of application? So this is sort of a go-to-market strategy. We are now solutions for decentralized application for dApps. Why is that? Basically, when you deploy a smart contract on Ethereum, for instance, you have access to very limited computing capabilities. So this is typically a few kilobytes of storage, a few kilobytes of memory, and you don't have any solution to go what we call off-chain. So for instance, if you need to get some information such as the price of Bitcoin versus US dollar, this is not an information you can find on-chain. You have to go off-chain. So we are solutions for all these applications right now. Later, we think that once the network is more established, we can compete with, let's say, legacy applications that are running now on the cloud, and they would eventually go on iExec, on this kind of network, because here they can find some cheaper way of execute their application. And finally, I think in the future, we can be a solution, I mean, decentralized, let's say, decentralized cloud computing can be a solution for all those new applications that will come in the future, for which we know that the centralized COM is going to be a bottleneck. So here, think about self-driving cars, IoT with many devices, video, etc., etc., etc. And as it has been mentioned before, typically you need 5G or new edge computing for computing. And here, yeah, there's a need for decentralization because of the infrastructure. So one thing that is key in understanding decentralized computing is the fact that there is a token. There is a token. I mean, it's associated with a cryptocurrency. So in our case, the name of the token is RSE. This is a token we issued in April 2017 during a so-called ICO. So ICO means initial coin offering. So it's basically we have emitted a fixed number of tokens, it was 86 million, and we sold them against Bitcoin and Ethereum. So this was in France probably the first ICO, or let's say the first major ICO. So it gave me the opportunity to talk with the governments and Senate and the Assembly, and thanks to this adventure, now in France we have a great legal framework for doing ICO. So the government has been quite supportive for this sort of economy, for this side remark. So what's really important is that we did this ICO because we had to manage, I mean, in the protocol, we had to manage value, and we had to build some sort of incentives. I will describe that later, but we had to manipulate value. We have to design the protocols around the exchange of money. And for doing that, a cryptocurrency is really the ideal tool, for someone designing algorithms. And basically, this is the reason why we did this ICO in advance compared to many others is that basically, as the token has to have a value, the best way for doing that was just to sell it. I will give an example of how it. So, as I said, we are creating and distributing infrastructure for those dApps. So it means that they are running. There is a laser. Maybe here. Okay. So this is the blockchain. So this is the way users interact with the blockchain through a wallet usually. And what we are doing is that for every application running as smart contract, we're giving them access to a distributed infrastructure. So here they can find application, they can find data set, and they can interact with those data set and information going off-chain, on-chain. And we do we do all the technology and the building, the bricks that makes it safe, secure, and etc. So basically it works this way. We have what we call requesters. So requesters they will create what we call the task, and the task is a triplet, which is a data, an application, a data, and some compute power. And once we bring those three things together, we seal a deal. The deal is recorded on-chain, and then we have the mechanics that distribute data, deploy applications, do everything. And there is something really important, is that we have a consensus protocol that we call the proof of contribution, and this consensus protocol will basically verify that everything happened according to what has been asked for. So there is one notion that is really key with decentralization, is the notion of trust. So here, when you are a requester and you want to execute an application, you request the execution of an application with a certain level of trust, and that's a parameter. So this is something new that typically does not exist with centralized computing. Basically, you go on Amazon Web Service because you trust them, but you have no idea of, if it went right or wrong. I mean, it's not something you can control. Here, you can really control it, and basically, the more trust you want, the more it's going to be expensive somehow. So we have this consensus protocol, and the consensus protocol is going to terminate the algorithm once the level of trust for the execution of the application has been met by the network. Oops. So there is some sort of a verification, and at the end you get the result, and of course payment happens on-chain after everything is detected to be okay. So this allows for new economic model with respect to the way cloud computing is used. So traditionally, you go on cloud service provider, let's say Amazon Web Service, and typically here on Amazon Web Service, you have a list of instances, so you select one, and the price is different according to the instance, and sometimes it's also different from one region to another. So for the customer, this makes, selecting the correct instance and understanding the price ratio is it can be very difficult. Here the idea is with iExec is that we want to allow to trade computing power as a commodity. So think about that. When you fill, for instance, your car, the tank of your car with some oil, you don't care if the oil comes from Texas or Iran or Venezuela or whatever. You just want to fill your tank and drive. So here the same idea. You don't really care if the computing power comes from Amazon or wherever. You just want your application to have enough compute power and just go. And the marketplace, it allows for any companies or even individuals to monetize their idle computing power. So I will just give you an overview of the UI. So this is the UI, and as you that we do, and as you see, this really looks like a trading interface. So so this is the price of a task. Oops. So this is the history of a price of a task to execute a task in RHC. This is an order book, so it's really like a trading. This is an order book, so you have ask and bid. So ask means I'm a server, and I'm ready to execute a task at this price. And the order book here is, I'm an application, please execute my task at this price. And of course here you have several providers, you have several applications, and that means that at one at one time, at one specific moment, you should have access to the best price to execute your application. Assuming that there are many providers, of course, that compete. So here you have the recent trades, the trade that you made, etc., etc. So proof of contribution, this is a consensus protocol that will verify what has been done off-chain. So what is important here is that in this protocol there is the notion of staking. So staking, it means that every stakeholder in the protocol will have to commit some money. The protocol decides of who has done correct work. who has tried to do, to cheat, basically, and those that are detected as created some erroneous result will be punished. So we will take their stake and distribute it amongst the good actors. So it means that there is no incentives in behaving incorrectly in the network. And typically, you can do that thanks to the fact that we are using a cryptocurrency, and as that is really difficult to create such kind of thing. And what's important here is that because we are punishing the people, I mean, we are taking their money and we are distributing the money to everyone. So that's really important to understand that this kind of algorithms run on the blockchain is fully auditable, and nobody cannot modify this, and nobody cannot, you know, it's this question of governance is really, really important. We are also leveraging a lot of technology that comes from what we call trusted compute. So I don't know if you are familiar with this. So trusted compute, it's something that is getting more and more popular and easy to use. The most elaborated one is Intel SGX and Clays. So basically, this is a bubble in your processor. Think it as a sort of bubble where your computation is going to be fully protected. It means that even the owner of the machine will not be able to access the memory. So you cannot modify the application, you cannot spy the data, you cannot modify, etc. So this is something super important. It allows us to do full end-to-end privacy-preserving computation, and I think that we are probably the first one that can do that. So I will briefly give you some use cases just to illustrate the kind of things that we can do now. So for instance, we can do data renting. So data renting, this is something very interesting. It's basically, it means that you have your data, you have full ownership of your data, you will allow people to use your data, but they will never be able to copy the data, so you keep the ownership of the data. And they pay for the usage of your data. Okay? So typically with iExec, people that are providers that can make money are the ones who provide the compute power, plus the one that provides the data as in the renting mode, plus the one that provides the application. So a good example for that, it's typically an AI model. So AI model, so this is an example of an application. It's a semantic image segmentation. So it works this way. Basically, the input is an image, and the output is the image with some annotation, semantic annotation. So this is a tree, this is the sky, this is a body, this is the grass, road, etc. And the way it works is that you are giving doing this segmentation using a trained neural network. So a trained neural network is a data set, typically. So in iExec, it means that the requester will provide that, will pay for this data, will pay for the application, this is TensorFlow, and will pay for the one that provides the compute power. Training a neural network, it can be extremely costly, and that's difficult to do. You need to have access to a lot of data. It requires a lot of compute power, so it can be really costly to train a neural network, and if you have a trained neural network, you want to monetize it. So using a model such as iExec, each time your data set will be used to recognize an image, you will get a fee. Another example, this is something that we demoed at the RSA conference. It's a joint work with Intel, is that we are doing, for instance, privacy computation for medical data. So here the scenario is the following. Imagine a hospital. It has a lot of medical data, so typically this is very sensitive. And imagine you have a startup elsewhere, and the startup is able to do diagnostic using this data. And of course, you want to transmit the data, but you don't want to reveal the data. I mean, at least in France, it's totally forbidden to leak any medical data. So you can do that using this privacy preservation. So basically, the startup will do the machine learning algorithm, but the startup will never have access to the actual medical data. It will be always protected within the enclave, etc. So conclusion. Okay, so I introduced iExec. As you understood, there is a stack of decentralized technologies. It's not only blockchain; it's blockchain plus many other things. I think this is a very emerging solution at the moment. So we are always looking at new solutions such as sidechain, decentralized brokering. I didn't dig into the details, but as you can understand, these are very innovative works. I didn't talk too much about that, but there is something really important, which is the token economics. We are discussing with a lot of, with some economists in France, and they are very interested in this. Basically, token and ICO, you know, at some point, this was a little bit, you know, people used to think that this is not a serious, this is not something serious. Some economists think that there are interesting things with token economics. In perspective, as this has been said by Antonio, I think that this kind of solution, the goal is certainly not to compete with the existing centralized cloud. I don't think so. You always need some very, tightly coupled infrastructure when you do big data, for instance. We are not a solution for big data. But in perspective for everything which is around fog computing, edge computing, 5G, etc., this is probably the good technology to enable this. Thank you very much.
Actually, I have two questions. One, it seems to me you have this proof of contribution which you have to prove the correct execution of the code or the correct result. And so can you give a bit more details about that? Because as an example, as far as I know, proving smart contracts can be done easily off-chain, but it's not so easy in chain. In the sense that you have to have the source code, compute the bytecode, the actual function, and so on and so forth, but off-chain, not in chain. So my question is whether you can do something in-chain instead of off-chain in order to prove the correctness. And the second question, very simple. It seems to me that some of the application of your use cases actually are based on centralized computation, even if the market is distributed. Am I wrong?
I will first answer the first question. So the first question, so the proof of concept, the proof of contribution, this is the protocol. I will, maybe I can go in detail. Oops. Yeah, so the proof of contribution protocol is there to ensure that the computation that happened off-chain is correct. So correct does not mean that the result is correct. Correct means that the requester asks for this level of trust, and the network is able to give the result with the level of trust that was asked for. So if you ask for a totally paranoid level of trust, eventually the application, the computation is going to be replicated many times, and each time what we do basically is that we compare the result. But that's a framework. Think it as a sort of framework. So it depends on where the application is going to be executed. So for instance, if you trust Amazon Web Service and you know that the application is going to be executed on Amazon Web Service, then in this case we set a trust level of 0, which means first result comes and is accepted. If you execute on the internet and there are many machines that you don't know that can fake the result, then this mechanism happens. So the mechanism, this is the algorithm that is executed when computation happens on the internet using machines that are unknown and untrusted. So it's a mix between staking, reputation, and result certification. So result certification, basically it means that we duplicate the execution of the application and we compare the signature of the result, so the hash of the result, basically. And so basically, if the hash is the same, so this is for deterministic computation, of course. So if the result is the same, then so it works this way, basically. You have a requester that say, I want this level of trust, and I want to execute the computation. So let's say that the first worker that comes have the reputation and create a result. So according to the reputation, the result can come with a trust level that is on par with what has been requested. So in this case, so good, so forth, this result will be accepted. If the reputation is not good enough, it means that we will ask another worker to compute the same task in order to increase the trust level. So if the results are similar, are the same, so then probably the trust level will be reached and the result is accepted. If the results are different, there's a problem. I have two different results, so I'm going to ask a third worker, maybe a fourth one, in order to have one result that is accepted. When the result is accepted, if some of the results were different, it means that those that had a result that that was not accepted by the proof of contribution algorithm, they are considered as being bad actors, and so they will be punished. We'll take their stake and distribute the stake to the one that behaved correctly. Yeah, so that's a good question. The way we do that, it's not perfect at the moment. It can be probably better, but when you execute, so the model is what we call pay per task. So you pay for the execution of one task. One task belongs to a specific category. So there are maybe 6 or 7 categories, and you have to make sure that your task belongs to one specific category, and the category gives an envelope for the execution of the task. So this is the way we hide the heterogeneity. It means that when you have a worker, when you have a machine, you must make sure that you are able to execute the task according to the good category. So, exactly. So basically, people don't pay for one specific machine with that specific characteristic. They pay for the right to execute a task within a dedicated envelope.
Good morning, Professor. I have a question for you regarding two main issues related to blockchain. The first issue is the cost in order to perform the mining task. The second issue is latency, because you have to wait a lot before block will be in place. And the third one is the really distribution, because right now the three main consortiums related to blockchain are just in China. So what is your opinion regarding this? Thank you.
Yeah, this is an excellent question that we are facing in our daily activities. So at the moment, what happens with public blockchain is that the cost of transaction is extremely high. So for instance, with iExec, for every task execution, there is a huge overhead in terms of time and so in terms of cost. The cost for doing one transaction, the overhead is almost $0.50. So that's quite significant. So first question is, why do we have this overhead and why do we have this latency? It's basically because with public blockchain, you have a sort of collateral with the fact that you store value. So typically with Bitcoin, for instance, that's really the case with Bitcoin. Basically, Bitcoin is secure because somehow, it's a shortcut, but somehow when you do a transaction on Bitcoin, there is a huge amount of electricity that is used to do this sort of collateral. And that's basically what gives the security of Bitcoin. So somehow, my opinion is that with public blockchain, this will decrease for sure when people will move from proof of work to proof of stake, but this will always be significant. So what we are trying to do with iExec is to create what we call the domain-specific sidechain. So in this sidechain, we will have all the consensus, so for instance, all the results of the proof of contribution consensus protocol, so that it's auditable by everyone and the rules are clear and are managed by everyone. But on this domain-specific sidechain, we don't have to manage any value. Okay? What matters in this domain-specific sidechain is to store the task, the deal, etc., etc. So basically, the way in the future, I think it's going to work for probably any utility token, is that you have a domain-specific sidechain that is managed by the stakeholders of your network, of your business. So here, typically, that would be, for instance, the worker pools, the main application. So they will administrate this sidechain, but there will be no value. And the value and governance will be managed on-chain, so for instance, on Ethereum. And here, if we do that, we can be much more efficient. In this case, we can leverage SGX. We can use Zk-Snark to have much more scalability. So I think we can have really efficient solution.
Just one additional question on the consensus mechanism, please. You've mentioned the proof of contribution. Can you give us an idea of how you've been handling the relation between the proof of contribution at network level and at app level, and if you've seen how you've managed the discrepancies or the conflicts? And second question, what is the weight of the staking in the global proof of contribution scenario that you have envisaged? Thank you.
Yeah, so the proof of contribution protocol is implemented as a smart contract running on the blockchain. So it's implemented as a smart contract, and basically what happens is that every actors, so for instance, the one that do the computation, we have what we call a scheduler. The scheduler basically schedule tasks to workers. So at some point in the protocol, they have to commit a proof of what has been done. So for instance, the worker at the end will look at the result, compute a hash, and we commit this hash in the as a transaction in the proof of contribution smart contract. So there are several steps, such as reveal. So at the end, everyone reveal the result, etc., etc. Staking is a very good question. So staking, so the question is how do we compute the ideal, the optimal value for staking? So if the value is too low, the incentive is for workers to, because the staking is low, less than the gain from the computation, I can create a fake result, and my chance of being detected, and we don't lose any money. So, but if the stake is too high, then there is an incentive for workers to collide together, to work together in order to steal someone else's stake. So basically we did simulation, and there is an optimal, which is around, I think it's 3 times the price of a computation.
But it's dynamic with dynamic thresholds.
No, it's not. It's variable, but basically what happens is that the price of a computation is set by the scheduler. So if the scheduler changes the price of the computation, yes, you basically need to adjust the stake. So basically what we say is that the workers should, we ask the worker to have enough money in their wallet to be able to stake the correct amount of money at a given time. I think it's set by the scheduler, if I remember.